Hello, so welcome to Math2526. So last class we introduced normal distribution. We say many things follow normal distribution. So for normal distribution, we denote this as x or something follow a normal distribution with mean is mu and standard deviation sigma. So from a normal distribution, we want to find its related probabilities. So at first, we just check a simplest normal distribution, so which is standard normal. So standard normal is mean is 0 and standard deviation is 1. So we can regard this is the simplest normal distribution. And usually we denote this as z. Okay, so z for standard normal, we denote this as z. So for standard normal, we can find the probability by checking the z table or normal table. So we call such a table as z table. Okay, so the question now is how to find the probability from general normal. So the first we need to convert general normal to standard normal. Then we can check the table, right? So here we have this formula. We say from a general normal, so x follow this general normal. Then x minus mu divided by sigma. This become standard normal. Okay. So we can call this from x, we changing general normal to standard normal. So let's consider this problem. We say like x follow this normal. We want to find this probability. So for this probability, so this general normal, at first we change this general normal to standard normal, or changing this x to z. So z larger than. So how can we change this x to z? Just minus mu divided by sigma, right? So this side, the right side also need minus mu divided by sigma. So here mu is 12, sigma is 4. Okay? So minus mu divided by sigma. So then this become a distribution from standard normal. So z larger than, so here 3 over 4, 3 over 4, 75, right? Okay, so for 0.75, okay, 0.7, our cutoff point is 75. So we want to find this side, large side. So the normal table, the z table give us left side. So we need to do this, equal 1 minus, so we just check 0.75. So check 0.75, we can get this number from the table. So let's go to the table, find this 0.75. Okay, so 0.75 this, right? So there's 7734. So let's go back. So we say just 1 minus. So that's equal 1 minus 0.7734. So we can get this, right? Okay. So for this one for B, the same way, like at the first step, we just changing this to z, changing x to z. So how can we? So we just minus mu divided by sigma on both sides. So here also need a minus mu divided by sigma. Okay, so So this equals z less than -1, right? So -1.00. So how can you find this probability? So the table we have only positive, so -1. So here -1. We want to find this probability. So if we just check a +1, so we know this probability equal like less than -1.00 equal like larger than 1.00. So find the larger than, so we need to use this, just 1 minus left side, right? Right side equal left side. So right now, so we can check a table. So 1.00, so check a table. 1.00, 1.00 is here, right? 8413. So we can find this point. 8413. Okay, and equal. Okay, so this is some simple example for find probability for normal, general normal. So the idea is change general normal to standard normal, then check a table. Okay. So as some application, let's consider those kind of problem. Suppose X is the ACT score for all people in this year, and we assume these things. ACT score for a normal distribution means 550 and standard deviation is 80. So this 550 we can regard as average for all people, right? And 80 standard deviation is change, average change between students to students, among students to students. Okay? So here U score is 16. We want to find your ranking. So the ranking is just the percentage of people, percentage, let's say, set below yours. Okay, so here this average is 550. Okay, so your score is above, clear above average, right? So we wanted to know what is the percentage of people below yours. So this percentage is just such a probability. We can say that if we just this probability x less than 16, right? If we pick one person or the other person's score is less than 16. Okay, so this percentage is just such a probability. So how to find this probability? So we say right now it's easy, right? We at the first changing this to standard normal, changing this x to z. Okay, so less than, keep this less than. So this minus mu, or mu is 550 minus mu divided by sigma. So here we need a little bit of calculation. Let's see this number. So let's use calculate. Let's use calculate, do this little bit of calculation. So 16 minus 550, so divided by 80. So we find this equal 75. So for this number, okay, so changing to standard numbers or this probability, we can check directly from the normal table. So we just check 7.75. Let's go back. Let's check this table 0.75. 75 we checked before. 75 7734. Okay, so that's equal 7734. So we, in terms of percentage, we say 77%. So we can say your ranking is 77, or we can say 77. There are 77% people below yours. Okay. So this example, this problem is quite the same. Like we want to find the percentage of people who are not as tall as yours. So it's the same story, right? Okay, so the height of people follow this normal 5.52, average this, standard deviation this, and your height is here 6.10. So we want to find how many people, what is the percentage of people who are not as tall as you. So you are very, very tall. So how many, what is the percentage people below yours? So this probability, this percentage is just this probability, right? X less than 6.10. So we say this problem quite the same as that. So changing this to z, then this minus mu, mu is this, divided by sigma. Okay, so this, so here, a little bit of calculation. So let's say 6.10 minus 5.52. No, sorry, 6.1 minus 5.52 divided by equal 2.9. 2.90. Okay, yeah, 2.90. Okay, so we just check the table 2.90. 2.90. So this means there's a probability 95, right? 95, 81, almost 96%. So 96%. So you are really tall, like so you are at the top of 4%, top of 5%, top of 4%. Okay, so those are two examples for application for normal distribution. Okay. Okay, so let's say we introduce this normal distribution is because we want to solve this binomial distribution. Okay. So like in our first exam, suppose we have 20 questions and each has 4 choices. So we want to find this probability. Find this probability. Like you can get at least 8 questions correctly. Or we consider this as the passing grade. If you get at least 8 questions correctly, I let you pass the exam. So this exam can be understand like, oh, how much chance I can passing the exam without by by landing picking, okay, passing exam. So such a probability, we really wanted to find the numerical solution. We don't like the formula. We can have a formula, but we don't like. We wanted to know how much a chance, or like a 20% chance or 10% chance. Okay. So for such a problem, we say one method is used by use normal approximation. Like a story like this. So here, this is just come from computer. So if we use computer, we can find that larger than at least A can be 8, 9, 10 until 20, right? But here we don't want to use a computer, so we use this. Okay, so we use this normal distribution to solve this problem. Okay, so we can say the binomial distribution looks like a normal distribution. So for binomial distribution, we have mean. So remember, mean is mu is NP, and the variance is NPQ. So for the normal distribution and this binomial distribution, the mean and the variance should be the same. So we have this result. We say a binomial distribution will close a normal distribution with the mean is NP and with the standard deviation NP, square root of NPQ. So variance NPQ, then sigma is square root, right? NPQ. So we have this result. So use this result, we can solve our problem. Okay. So now x, we say originated from binomial distribution, but we just change it to normal distribution. We say this x follows. Let's check also what is mean. Mean. So here n equal 20, right? And p. Each question we have 4 choices: 1/4, or 0.25, 1/4, or 0.25. So NP, so mu is NP equal 20 times this. 20 times 1/4, 20 times 0.25 equal 5. So mu equal 5, and the variance or standard deviation sigma equal NPQ. So here we need a little bit of calculation. So n equal 20, p is 0.25, and q is 0.75. Then take square root. Okay, so we find this sigma equals this 1.94. So we have this result. We say now this x will follow this normal distribution with the mean is 5 and the standard deviation 1.94. Okay, so now such a problem like larger than 8, we can regard this as normal distribution problem, right? Okay, so here here larger than or equal, at least larger than or equal 8. So So here they have some difference, like binomial distribution is discrete distribution. And normal distribution is continuous distribution. So for continuous distribution, let's say larger than or equal 8 and just larger than, there's two probabilities the same, or include the point or do not include the point. It doesn't matter for continuous distribution. But for discrete distribution, they are not equal, right? Include this or do not include this, or larger than, do not include this, they have significant difference, right? So in order to guarantee we include this x equal 8, so we just make it smaller. So we change this to x larger than 7.5. So let's say like for normal distribution, so we just start from 7.5, like start from here. Okay. Then use this to, sorry, 8, like, sorry, 8. So 7.5, so guarantee we will include this 8. Okay. Okay. So for this one, so by now to find this probability is become a routine. From normal distribution, we find the probability. So we say first step, changing this to z, right? Changing to standard normal z. So larger than, so this minus mu divided by sigma. Okay, so then calculate a little bit, so larger than, so let's say this equal 7.5 minus 5, 7.5 minus 5, so divided by 1.94 equal, or 1.29. So to find this probability, so we know, so larger than, so the normal table give us less than, so we just use 1 minus, right? 1 minus less than. So less than, we can check this from the normal table. Okay, so 1.29, 1.29, let's check standard normal. 1.29, okay, 1.2, okay, 1.29 is this, right? 1.29. Okay, so 9015. So 9015. Okay. 9015. So we can say you have like about a 10% chance to pass the exam, right? Or if more precisely like this, right? Okay, so this answer is better than the formula. Right? Formula for binomials, the formula is like this. You at least equal at least a question correctly. We say we can use this. Like from 20, we just pick k questions. For these k questions, answer correctly, and other questions not correctly, not correctly over 4, right? Then other is 20 minus k. So we just let k start from 8 to 20. So from binomial distribution, we just can only get this formula. But for this answer, we said we are not satisfied. We are not happy for this such answer. We prefer like a numerical answer. Okay. So use this way use normal. We call this as a normal approximation of binomial distribution. Use this approximation, we can solve binomial distribution problem. So let's do one more such a question. Okay, now suppose in our test there are 100 true false questions, yes or no questions. So each question was 1 point. So you suppose that you just pick your answer randomly, and we want to find this probability. So we just 60 point is passing score. So okay. So we want to find this probability. So this at the first we say there's no binomial distribution, right? So here n equal 100. N equal 100. And P equal 0.5, like yes or no, like yes or no. Also like only 2 choices, true, false. So the chance you can get the correct answer is 50%, half a percent, right? So P equals this and Q equals this. Okay, so we say originally such X, the number you collect answer, follow this binomial distribution. So we use this notation, binomial distribution. Binomial distribution, we just need NP. So here, let's say binomial distribution N is 100, P is 0.5. So this binomial distribution, we use normal distribution to approximate this or to close this binomial distribution. So we say this binomial distribution will close to such a normal distribution. So mean is NP. Right? So let's say mu is NP. We just use the formula. So and sigma square equal NPQ. And sigma equal NPQ square root. Okay, so NP equal 100 times so 50, right? So we say mean is 50. So we can say this 50, most likely you can get 50 questions correctly. But we need 10 more, right? 10 more questions correctly, you can pass the exam. 10 more. So, and so what is this sigma? So NPQ. So let's do some calculation. NPQ equals sigma equal N 100, P 0.5, Q 0.5, and take a square root. Oh, we find this equal 5, right? This equal without the calculator we can find that this square root is 10, this square root is 0.5, so this is 5. Okay, so we say such a binomial distribution will close to this normal distribution with the mean is 50 and standard deviation is 5. Okay, so 50. So we want to find what is the probability that will at least 60. So we want to find the probability x larger than or at least 60. Okay. So here, so we can use 60, or more precisely, we should do this. Okay, let's see. We just say we wanted to guarantee it will include 60. So we just put 95.5. Okay. So why we need to use this? So this is just because discrete situation equal or not, or include this or not include this make a difference. But the continuous distribution is the same. So here, in order to make sure we include this 60, we use this. Okay. So now this probability is just become routine, like change this to z, right? So larger than, so this minus mu divided by sigma. Okay. Okay. So this equal 9.5. Let's see. Here just a little bit of calculation, minus 9.5 divided by 5 equal 1.90. Okay, so check this probability. So we need to use 1 minus, right? 1 minus. So we just check 1.90 from the Z table. 1.90 1.90 says 9713. So 9713. Okay, so 99713. So this is, so we find this is just a 0, like 003, or just 3%, about 3%. So we can say you without any study, you can pass this. You can get 6 question. You can pass the exam is not so likely, because the probability is 3%. Such a probability is really small, right? So you cannot expect to pass the exam without study, or just by your lucky. Like you cannot be so lucky. Okay. Let's see. Okay. Okay. So this today's topic. So today's topic, we mentioned how to find general normal distribution, general normal probability. So we just convert general normal to standard normal. Then we can check the table, right? So this is one thing. So other thing is we use this for binomial distribution. We just convert or change the binomial distribution to normal distribution. Then we can solve binomial distributions problem. Just like this one or these 2 examples, right? What is the chance you can get at least this number correctly, or at least how so many things happen? Okay, so like for those are typical examples for we say the approximation for binomial distribution to a normal distribution. Okay, so we say for binomial distribution, if this n quite big, like n equal 100, n is quite big, then we use normal distribution to solve the problem. Okay, so this is today's topic. Okay, so we can stop here and so see you next class.